Okay, we're going to do a little video here about how to do the crystal violet lab. We need some crystal violet, we need some sodium hydroxide, and they'll be in a water bath where we can record the temperature. This one happens to be at about 19.4. We need 2 graduated cylinders, 1 for each solution. We need a vernier colorimeter, and we need vernier graphical analysis open up on our computer. So first thing we're going to do is take a disposable pipette and put about 2 milliliters of NaOH in this graduated cylinder. Okay. And we're going to do the same thing with the crystal violet, obviously using a different disposable pipette. Okay. Now, my colorimeter, I'm going to open that up, and I'm going to take a cuvette and just put some water in here so I can calibrate it. Okay, since it doesn't have a color, it should read 0, so we're just going to push the calibration button and wait. I'm using 565 nanometers, that's kind of the optimum wavelength for this lab. Okay, I'm going to take this out. And I have another cuvette here. So the idea here is I'm going to pour these 2 solutions into a little beaker. Move this out of the way a little bit. And then I'm going to put the cuvette into the colorimeter as quickly as possible, close it, and hit collect. Okay, so you don't have to rush too much, but quick swirl, pour. Make sure you put the cuvette in the proper way. I close it, and I hit collect. That's not a touch button. And you'll see that it's starting to collect some data, if I get the stuff out of your way for you. So what's happening is when you add crystal violet and sodium hydroxide, a reaction takes place, and the colored solution of crystal violet produces a solution that is colorless. So we're seeing the color disappear here. We're seeing the absorbance decrease as the color goes away. So we're going to kind of keep going here until we feel like, you can usually tell when it's done. It'll kind of jump down to 0 kind of suddenly. So see, it just kind of jumped down there. So it looks like we're done. So I'm going to go ahead and push stop. Okay. Bring my computer a little closer here. So what we're going to do now is we're going to come into this data table, and we're going to, whoops. So up here in the right-hand corner, I can choose, this box here, I can choose table. So now it'll give me a table of all the data. I want the times. I'm just going to take, I don't actually want the transmittance, but I think it'll be easier to collect it all at once. I'm not going to go quite to the bottom. I'm going to ignore those last 2 buttons that just look like they're 0. And I'm going to copy this. I'm using an Excel document, but you'll probably use Google Sheets. Just going to punch this in here. And I don't need this middle column, so I'm just going to get rid of it. Okay? And then, oops. Okay, so this first one here is the time. This second column is the absorbance. if I could spell. And then we're just going to go ahead and we're going to make a graph in Google Sheets because it's going to be easier for us to work with it later rather than having it in GraphNow. So I've got my graph. We'll label everything properly, and then you'll see in the lab that you're going to graph. This is absorbance versus time. We're also going to graph 1 over absorbance versus time and ln of absorbance versus time, and we're going to see which one gives us the straight line, and that will tell us what order the reaction is. Now you're going to do this at 5 or 6 different stations at different temperatures, because then at the end we'll have a bunch of Ks and temperatures, and we'll be able to find the activation energy of the reaction. So that's the lab.